Hi, today we're going to set up an ODrive using the ODrive Web GUI. We're going to go step by step and we're going to set up an ODrive S1 using the documentation as our guide. To get to the Web GUI, you would go to gui.odriverobotics.com and the documentation is at docs.odriverobotics.com. You can get to either from the links up here in our homepage. So today we're gonna set up a ODrive S1 and I also have a D5312S motor and a AMT212B VOD encoder and a USB cable with a USB isolator. Alright, so the first step is to wire up the hardware. I've already prepared this, but just quickly, you want to wire in the motor phases, the motor thermistor, the power input, and any anything you have on the logic side, such as the encoder or any other input sources that you may have. It's very important to make sure everything is tightened down and give it a tug test to make sure nothing's coming loose. I also have the motor bolted down here, and so it's not going anywhere. Alright, so I don't have any power on yet, and I'm going to plug in the USB cable. One thing I want to show you here is, in case I don't have this open, I can plug it in. I get a little pop-up here, click it, and it takes me here. If it doesn't work, you can just get to it the normal way by typing the address or using a link. Okay, so the ODrive is plugged in, and we click here to connect. So give the browser permission, and here we go. So the first thing you see here is that we have our ODrive here, and this is our parameter tree. If you're using, or if you've used ODrive tool, you may be familiar with the parameter tree. This little box here gives us all the important information that we might be interested in terms of the status. We have the serial number, the status, any errors, and any feedback from the various procedures. This circle here reflects the color of the status LED. This button here is if you have been talking to a different ODrive before and you want to rebind all the different controls we're going to be setting up here to the new ODrive, you can use this button. Okay, so let's set up this ODrive. I have a 20 volt power supply. It's a bench power supply. So I'm going to use this tab here. So yeah, we're just gonna go step by step and follow these instructions. So I read this before, so I know which valves I'm gonna be picking here, but I invite you to read through this carefully and that goes for all these steps, to decide what makes sense for your setup. So you can search for these DC bus overvoltage trip level, and you add them here. So we're building a dashboard of all the controls we're going to be using, because there are way more parameters than we need right now. So we only lay up the ones we're going to use. Okay, so DC bus overvoltage trip level. It says to put a value above the nominal value of your power supply. This is a safety limit. So I have a 20 volt supply. I'm going to put 30 volts here. I think that will be sufficient to protect the power source from any overvoltage. The max current draw before we fault. I believe my power supply can do 5 amps. It's just a bench power supply, but it has internal limiting. My power supply does. So I think a safety limit here, we can put something a little higher, maybe 8 amps. And then the max negative current, that's how much current we can push back into the supply. My power supply cannot handle any current in reverse, so I'm going to leave this as a default of just 10 milliamps. This only works if you have a brake resistor, so it can dissipate the current elsewhere. If you don't have a brake resistor, you may want to set this a little bit larger, a little bit more negative. All right, so we're going to set up the brake resistor. We got resistance and enable. So I have a 2 ohm resistor. Yes, I would like to use it. And then save configuration. All right. We're running save configuration. The ODrive reboots, so that's why you see the splash screen come up. All right. Let's see. After doing any significant thing, it's always good to keep an eye on the status. And I should mention here that the status we have now is initializing. This actually means that the inverter, the power stage, is initializing still, and we have DC bus under voltage. And the reason it's still stuck initializing is because my high voltage power is turned off. My 20 volt supply is still off. And I mean, this is what we see here. I'll be turning it on in a bit before we start, right when we need it for running the motor calibration. All right, so let's see. We're gonna set up the motor. So I have a D5312S that is not represented in any of these tabs. These pre kind of configured tabs. So we're gonna use other, and we're gonna go through this kind of custom motor section. All right, so motor type, the choice is gimbal motor or high current motor at the moment, and this definitely falls into the high current motor. Essentially, the gimbal motor should only be used for gimbal motors. High current motors for everything else. So motor type, high current. Okay, we have that. Good. All right, let's see, pole pairs. I'm gonna just put them all out and then we'll set them up. Torque constant, calibration. Let's see, motor, calibration current. And then I think we also have calibration lock-in current. I skipped this one, resistance, calib max voltage. That's this one. And okay, so let's see. Pole pairs, let's go check the motor. It says 14 poles, so there's 2 poles in each pole pair, so I have 7 pole pairs. That's the default here, so that's all right. Torque constant, 8.27 divided by kV. Let's see, we have a 330 kV. So let's do that. 8.27 divided by 230. I pressed enter there, and we got their value. Calibration current. Half the continuous current rating of the motor. Okay, I think this motor is 30 amps continuous, so I'm going to put 15. Resistance clip max voltage. The default is typically 5 for most high current motors. I think that's the case here too. And half the continuous current rating of the motor. Okay. Motor thermistor. So at the moment, the GUI cannot set up thermistors. We're working on fixing that. It should be ready pretty soon. But for now, we have to skip that in general. I would strongly recommend using motor thermistors. But we cannot do that at this time with the GUI. You can still do it in ODrive tool though. So, but we'll have it fixed for the GUI pretty soon. So check back here. We'll have new instructions in a couple of weeks from now. And all right, run motor calibration. So we need requested state. I'm gonna leave these ones. I'm gonna use a lot. I'm gonna put them at the top here. I think we'll end up using those quite a bit. Requested state, motor calibration. All right. Oh, okay. We got a red LED here, and the last error here is initializing. So that means the high voltage. The error was that the high voltage stage isn't ready yet, and that is because I don't have the 20-volt supply on. So I'm gonna turn that on. Okay. All right. Clear errors. Okay. So now we should be good to go. Let's try that again. All right. Okay, I think we have procedure result success here, so we're good to go. Yep, we didn't yield any errors this time, so we can save configuration. I'm going to do that. And I'm just curious what... So the motor calibration gets you the resistance and inductance, so I'm just going to have to take a look what that was. Mostly because I'm curious. This is actually... we won't really need to do anything with this information. All right, we got 29 milliohms and 19 microhenries. That is reasonable for this motor. Okay, so let's go to the next section. All right, well, setting the limits. So this is the current limit for the motor. Notably, the motor current is not the same as the DC battery or power supply current. Usually the motor current is can be much higher. You can read more about it here in this area of the documentation. And it says here recommended to set something quite weak to start with. So that's what I'm going to do. It's always good to start low and turn it up when you have some confidence. And this motor can take much more than 10 amps, so if you want the full performance once you've tuned it, you can turn it up. But we're going to start nice and low. So, so we got, yeah, you got to make sure you have the correct one if there are some things called the same thing. So here, it's this axis config motor current soft maximum one, and not this one. So just something to pay attention to. All right. So looks like the softmax is already 10. That's what I was going for, and the hardmax is 20. I think that's good to start with here. On a motor whose current rated current is lower, you would have to lower this, of course. And if this is like very close to the rated current, then this wouldn't be a nice and low value to start with. You might want to lower it as well. In this case, 10 amps is fairly, medium low for this motor, so it's a good place to start. All right, and we'll check out the velocity limit. It's set to 10 turns per second. I think that's nice and slow for a good place to start. That will also have to be turned up once you build some confidence and want to go fast. Temperature limits. All right. And I would not suggest changing the FET thermistor. That's for the inverter. Those defaults are good. But the motor thermistor, we can have a look. And here we can have a look here. it basically has a ramp where it ramps down the current, and when you're within the range of these configured points, so it will start scaling back the current at 100 degrees Celsius and have reached a 0 point at 120. So this is usually reasonable for many motors. We don't have the motor thermistor set up in this session, so it won't be used, but if you have the motor thermistors working, this will be useful. All right, next step here, AMT21 is what I have. I have the AMT212B VOD variant. All right, so AMT21 encoder group 0. Let's see, config event-driven mode. Enable, and I'm also going to look at the status and raw values here to see how it's going, and we'll start with those. So I'll set the event-driven mode to on because I have this variant, and we'll turn it on. And see here, the units here are in turns, so this is in units of milliturns. So this is expected to go between, between 0 and 1, but you get engineering notation here. So yeah, I'm turning it by hand now. This all looks reasonable. One thing we can take a look at here is dropping the values into the plotter here. Notably, I don't think you can drag it from here into the plot. That is something we may want to add in the future, but right now you have to drag it from over here. So we got the raw value of the encoder here. All right, yeah, this looks completely reasonable. All right, we can stop that from going across the screen. Yeah, you can hit start and stop here. All right, and then, so the way it's set up is we allow multiple different encoders, and they can be mapped to different functions. So now we've turned on and configured the encoder, but now we're gonna map it to be used by the different modules. So in this example, we just have one encoder, so we're gonna map it to both the position velocity control loop. We call this load encoder, and we're gonna also map it to the FOC motor commutation. So this is the commutation encoder. If you only have one encoder, you would just set it to both. If you have, say, a gearbox where you're running the motor with one encoder and you have a precise high-resolution encoder on the far side of the gearbox, you could set the one on the far side of the gearbox to the load encoder and the one on the motor to the commutation encoder. But I only have one, so I'm going to set let's set it, the one I have, to both. All right, so we got our AMT encoder 0. All right. Okay. And save configurations next, so we'll do that. And okay, so now we're gonna run encoder offset calibration. So what this does is rotate the motor using the by energizing the coils, and then seeing what the encoder does in response, and that helps align the motor's rotor phase to the encoder. We don't assume any particular angle offset between the encoder and the motor, so that's why that's calibrated. If you do disassemble the motor and encoder and put them back with, essentially if you disassemble it at all, I would recommend that you rerun the encoder offset calibration. Okay, request the state. So here, I'm going to show a trick here. Or it's not really a trick, it's a feature. If you press on the white area of any of these, it opens up the little extra panel here. And for for these enums, you can add send buttons. So, or like it's called a quick send button. So I would say I want idle to be 1. That means off essentially. And I want motor calibration. I want encoder offset calibration, and I want closed loop control. Those are the ones I think we're going to use today. So now I got these quick buttons here. All right, and we're running encoder offset calibration. All right, so green, we got green LED. I can see it go here. Cool. All right, procedure result success, great. And save, yep, so we got our encoder offset set up correctly. We got success. All right, so let's save that. Cool. All right, so this is the raw encoder angle. It's a little kind of annoying that it jumps around like this. It won't be able to track position properly, but this is the raw, so let's skip that. And here it talks about how to view something more useful. So we got this pos melvap or pos rel. Right, and so this is a actual if I keep spinning it here, it keeps going. So this is something that actually tracks position properly. And the units are in turns, so I spun it a couple turns there. All right. And we also have so pos rel is relative position. The term relative here means that the kind of it's relative to the startup of the ODrive. It's guaranteed to never jump is the main property. And then we have pos abs for absolute position. This you can move its reference offset or its reference point, and it would then maintain an absolute position from that reference point that you set. And so, but you have to set that up. So that's why the first hint here is to just look at pos rel. If you do want to set up a absolute position, there's some documentation for that, but it's not part of this initial setup guide. All right, here's oh yeah. So I think we talked about this. The blue is idle, green is go, and red is error of the LED. All right, so we have done all the calibrations and the setups, so I think we're ready to just make the motor go. So request the state closed loop control. The mode that we have by default is position control, so we can start with that. You go into other control modes here, but this is just making sure everything is working. So request the state closed loop control. All right. So now it's holding here. It looks noisy because it's really zoomed in. If I push it by hand, we have a little bit of a PI control loop action there. Yeah, it's not tuned the most aggressive, but that's good to start with. Every application, load, transmission, motor, tuning will be different. So you can tune from here. But yeah, so let's try sending it somewhere. We got input position. So input pos. I'm gonna drop this at the top here as well. So input position is where we started. I can, in fact, add a slider here. So I'm gonna operate this slider from minus 10. Let's do minus 5 turns. 5 turns. Minus 5. 5. Save. All right. So yeah, that's this jumpy motion is because I'm moving my mouse in some steps here. But yeah, it's doing the thing. All right. Yeah, so the next step, if you want to keep position control, of course, then you're done here. And the next step would be to tune the motor and start turning it up and making it more higher performance. There's also the other control modes. For quite a lot of robots, velocity control is more important, especially wheeled robots and continuously spinning things, spindles and so on. We also have trajectory control and filtered position control and torque control. Those are the and some other ones as well. We can have a look at some of those now. Let's look at filtered position control. So as you noticed, when I move the mouse here, it gets kind of a jerky input, and the motor moves kind of in aggressive, hard steps. So we can change this by adding a filter. So the input mode now is pass through. So the raw value I send here goes directly to the position controller. So if I change this to position filter mode, then it will get filtered. So the input filter bandwidth here is really slow. In a application where you're sending set point from another module like a Raspberry Pi or an Arduino or something else, something over CAN, and that comes in at some rate, 50 hertz, 100 hertz, that will also cause a stair step like this, but at a much faster scale. But that may also want to be filtered. So you can set the bandwidth to filter those to, if you send at 100 hertz, you can set the bandwidth to 30, for example. If I send my mouse steps here at 2 hertz, then I might want to set the bandwidth to 1. Something a bit lower than the rate that you send commands. So we can try that and then set this to position filter. Okay, so now it's way smoother. Okay, I think that's a little too slow. Increase this a little bit. So now you can see it kind of smoothly tracks where I'm moving this. Yeah, it moves very nicely in person here. Another thing we can do is trajectory control. I won't do that in this demo. You can read here. You can essentially do a go-to point. It will accelerate, go to constant velocity and stop. And but what I will show is velocity control, because there's quite a few. That's quite common. So let's go have a look at that. So the basic one is essentially just set the control mode to velocity control. Notably, it doesn't work together with the input mode for pulse filter, so I'll set that back to pass through for now. But we'll set the control mode here from position control. We'll set it to velocity control, and we'll have a look at the velocity on the plot here, and we can turn off the position. So now we're just looking at the velocity, and we've set the velocity control, okay, and then so input bell. So we give it a velocity set point here. All right, so we can start with, oh yeah, and it's spinning. We can do the same thing here with the slider. So I'm going to do minus 10 revolutions per second to 10 revolutions per second. It seems like we have to click out there. Okay, yeah. Yeah. Yeah, it's behaving well. And so one thing to note is that we set up this velocity limit earlier. This is kind of a safety limit, and we'll also limit the velocity in position control mode and in all modes except for a special case of torque mode if you turn off the velocity limit. So if I set the input velocity higher than 10, I mean, we can try. It won't go. It'll just go to 10 because of the velocity limit. So you would have to turn up the velocity limit to be able to do that. You see here, I'm cranking it, and it will only go to 10. But I think for my setup here for demos, 10 is good. So the next thing I'm going to show is the ramp velocity mode. So one thing, when there's a very sudden change in velocity and it's turned to be very aggressive or hold against disturbances really hard, a sudden step in velocity can make it behave very aggressively, and that can be kind of jerky and even kind of lead to wear and so on. So what we can do is we can use ramp velocity control. So that will smoothly ramp it to the target. So let's do that. So we have the control modes, velocity control, just okay, that's unchanged. We'll set up our ramp rate. Let's do that. The bell ramp rate, 1 turn per second per second. That's quite slow. We can start with that and turn it up after we've seen it work correctly. So input mode, instead of pass-through, so that means it's sending the input directly to the controller. We're gonna enable vel ramp. And okay, so now we can. So now if I send this immediately to 8, see ramps slowly up to 8 here. And that took really quite a long time. So the default here is very slow. So we can set it to something. I mean, for demo purposes, you can see it go. I'm going to set it to 5, but you can go much higher and still get something that's smooth. I can turn it up a bit. Yeah. Okay, and the last one is torque control. I won't show that here. I don't have a load. Usually if you have torque control, you want to drive it into a load or it's just gonna spin away. But it's pretty similar. You would have your input torque here, and by default it has a velocity limit, and you can see how that works here, and you can check that out if you need torque mode.